So this is going to be essentially a video on how to use Excel, specifically for the Enzyme Kinetics lab that you're working on. Now this first video is just going to be focusing on your data analysis for week 1. And just a couple things that I'd like to point out from the protocol before we get started. The protocol asks you to put your enzyme in row A, and then you have your substrate, 240 microliters, going in row B and row C. Your enzyme, you have concentrations of 250, 125, 50, 25, 10, and then 0 micrograms per mil. And then it's actually going to read data for 2 minutes, not 3 minutes, and it tells you you must convert from delta absorbance per minute to delta product per minute using the extinction coefficient. Prepare a graph of velocity versus enzyme concentration to show your TA for next week. So that's basically what we're going to work on, and I'm basically just going to be showing you how to do this in Excel. So a lot of tips and tricks that maybe some students aren't aware of. Now this is what your data is going to look like. I've added some hints right here. We're going to fill this in and use this to do our conversions. Now this is row B data and this is your row C data. The plate reader does not read row A because you're just putting your enzyme in there. Now, of the many things we need to do, first we need to convert time into minutes. So you see right here it's been given to us in seconds. We'll convert it into minutes over here. And then all of these are absorbance values. So we need to convert that to concentration in the correct units. And then we also need to average this data as well. So first things first, let's convert time from seconds into minutes. So I'm just going to label my graph, my chart, Just a good idea to label things as you go along. Now obviously we could calculate these very easily on our calculator. This would be 0 seconds would be 0 minutes, and 60 seconds would be 1 minute, or we can use Excel to do it for us. So I'm going to type in a formula starting off with the equal sign. Now to convert from seconds to minutes, we'd have to divide by 60. So we can just click over here on the seconds and then type divide 60, hit enter, and obviously 0 seconds would be 0 minutes. But now what we can do is copy and paste this down below. And you can copy, you can go copy, you can paste it. One trick you can do is pick up this little black square in the lower right corner and then just drag down. And as you can see, it copied everything. The formula changed as we copied, and 120 seconds would be 2 minutes. You can always double click on a cell to view the formula and make sure it's pointing at what you expect. And to get out of this, just hit the enter key without messing it up. And then we can copy this whole thing, paste it down here for row C. And there you go. We've converted from seconds to minutes, and that only took us about a couple minutes right there. Now to get rid of this, is still selected, I'm just going to hit the escape key. So now for the next part, converting from absorbance to concentration. First off, I'm going to go ahead and copy this, paste it over here. And I usually use the keyboard shortcuts a lot, but I'm going to try and use the mouse more so you can see what I'm doing. Oops. Copy, paste. There we go. Now we need to convert these absorbance values to concentration, to convert these absorbance values to concentration values over here. What do we use to do that? Beer's law. Now for Beer's law, we need to know the extinction coefficient and the path length. Now if you recall from the protein spectroscopy lab from last week, we learned a rule of thumb, which was the path length is 0.25 centimeters for every 100 microliters of solution in a plate. How many microliters of solution do we have this week? Well, let's go take a look at the lab handout to refresh our memory. As you can see, you were told to add 240 microliters of substrate solution to rows B and C, and then you added 10 microliters of enzyme solution to those. So your total volume is 250 microliters. So again, we can use Excel to calculate this for us really quick. We could also do it on the calculator, but let's use Excel. So 250 microliters. And then I'll just convert, so divided by 100 times 0.25. And please do this on your paper to verify that the units work out and it makes sense to you. I'll just hit the enter key, and we see we get 0.625, and this is centimeters. So this is our path length now. So extinction coefficient, what is that? Well, fortunately, you do not have to figure it out. It's actually given to you on the last page of the handout. See, it says important information, p-nitrophenol in basic solution. Extinction coefficient at 405 nanometers is 18.8 times 10 to the third, or 18,800. And pay attention to the units. It's given to you in molarity. That's going to be important in just a moment. So our extinction coefficient is 18,800, or you can type in 18.8, e to the third, same thing. I'll just keep it at 18. And I get this back into a number. Anyway, that is our extinction coefficient that we're going to use. And then our units, remember, molarity, centimeters, and they were inverse. So now let's convert. One more thing though, when we do convert, because our units of the extinction coefficient have molarity in there, the units for the concentrations are also going to be in units of molarity. They need to be in units of micromolar according to the handout and Dr. Lefler's recitation video. So how do we convert from molarity to micromolar? How many micromoles are in one mole? Well, there's 1 million. So basically we're going to have to multiply by 1 million. So our formula is going to be a conversion from absorbance to concentration using extinction coefficient and the path length, and then we're going to multiply by 1 million to get it into micromolar. And I encourage you to do this on your paper so you understand, because you're going to have to put these sample calculations in your lab report, even though you're having Excel do them for you right now. So again, we can just set up a formula, and we're going to use smart copy pasting so we don't have to type this out so many times. So absorbance to concentration, we're going to have to divide by the path length, and we're going to have to divide by the extinction coefficient. But first, the absorbance, so equal sign, and then I'll just come over here and click. So B1 times 0, come over here to B1 times 0 and click. Now I'll divide, and I'm going to use parentheses for order of operations because we're going to divide by two different things. Divide by the extinction coefficient, so I'll click up here, multiply, I'm dividing by that guy, close parentheses. Now I'm going to multiply because I want to multiply in the numerator by 1 million. So I've got absorbance divided by extinction coefficient divided by path length times 1 million. In the enter key, I get a nice whole number. I get 90 or so. Now, if I just copy and paste this, I get garbage. Why do I get garbage? Well, if you double click on the last one, you see now it's pointing at nothing in particular. It's pointing at this. We want it pointing up there. So what can we do to fix this? Now there's actually a trick in Excel. If you use the $sign, which is shift 4, $sign basically tells Excel to not change the formula when you copy and paste it, to continue pointing at what you're telling it to point at. So I'm telling it to point at M8 and M9. The $signs tell it to continue pointing at M8 and M9 despite any copy pasting I do. So now I'll try this again. Let's drag down here to copy, and you can see it worked this time. And we can copy across. So again, I'm just grabbing this little black square, picking it up and carrying it over, and we get nice whole numbers. This is why we put it in micromolar. If it was molarity, everything would be times 10 to the negative 5th or 10 to the negative 6th. Anyway, that's how we do that. Now all of these are in concentrations and they're in micromolar. So let's just label this really quick. This is our row B data, concentrations in micromolar. Now we can do the same thing down here. We're going to have to do the same thing down here for row C, but we already did the work up here. What we can do, literally, is just select all of this, copy, and paste it down here. And if you double click on one of the cells, you can see this is C6 at 2 minutes. It's pointing at C6 at 2 minutes. And it's still pointing at M8 and M9 up here, the extinction coefficient of the path length, and we're multiplying by a million. So there we go. So we've converted from seconds to minutes. We've converted from absorbance to concentration. We still should average these two. So let's do that next really quick. That's much simpler. Most of you probably already know how to do this. First, I'm actually going to copy, paste. I'm not going to copy this because we're going to put some different labels up top. But now let's do an average. So just in case you don't know, you can just do an average by typing an equal sign, typing out the word average. You can see it starts to populate. Average. Now, number 1, comma, number 2, so that's what I'll just do. I'll just click on this guy, comma, click on this guy, close parentheses, enter. And then we can drag down. So I'm just doing it by picking up this little black square, drag it over, and there we go. We've taken an average of row B. Taken an average. So I'm just double clicking on the cells to verify it did what I expected and then hitting enter. So I want to label these. So think about what you did on the plate. And if you go back to the lab handout, refresh your memory, you can see it said make your enzyme dilutions, put them in A1 through A5, and then the 0 is in A6. So that means in A1 you should have the 250 microgram per mil solution, and then the 125 in A2, etc. So that's what I'm going to label these as. 250, use proper Greek letters, microgram per milliliter. Copy this, and then I'll just label all the others accordingly. 125, 50, 25, 10, and 0. Oops. I'm going to copy this one more time. Didn't like that. Paste. There we go. So we've got time in minutes, absorbance converted to concentration, and we've averaged it. We're not quite ready to graph yet because there is one more thing that we ought to do. If you recall from the handout, it does say convert delta absorbance to delta, so I'm pointing at this delta thing. It also says that absorbance ratio is subtracting the times 0 absorbance value. So we're basically going to subtract off times 0 because the instrument's not zeroing our data. We're going to have to subtract off this times 0 from all of the data in order to account for that. This is basically just taking into account any initial absorbance, any initial yellow color that may have been present before the plate started reading. So this is also pretty simple, and I'm just going to copy this over. I'm going to keep working off to the right side here. Paste. And then I'll just copy these. Now, one thing I just noticed, and maybe you noticed it as well, see my times are all messed up now. Here they make sense. Here they're messed up. Why is that? Well, if I double click on it, you see it's pointing back at this 2 again. Now, one way you can get around this, I mean, obviously we can just type these in manually, but for the sake of showing you another trick, what we can do is copy, and then instead of just pasting, there's a menu here called Paste Special. And there's a bunch of things you can do in here. I'm going to tell it to just paste the values. If I just told it to paste all, it would paste the formulas and everything, and that's what happened. It basically copied the formula. But if we just tell it to paste the values, so you can see now it's been fixed. Now it says 0 to 2.0 like it should. So now if I copy this, we can paste it again. 0 to 2.0 minutes. That's what it should say. So now let's subtract off times 0 like we said we were going to do. Again, we can just do equals. Now I'm going to click on this, subtract, and then click on it again. Of course I get 0. That may seem kind of strange. Why did I just do that? Well, remember our dollar sign. What we want this to do is basically every single number underneath it needs to have this row subtracted. This row happens to be row 15 in my Excel right now. So in my formula over here, I can tell it to subtract, and I can tell it to just subtract whatever happens to be in row 15. I'm not going to put a dollar sign in front of the T, because when I copy paste it, I actually want it to change columns as I paste across, but I want it to stay pointing at row 15. So that's what I'm going to type in here. Now, when I copy paste this down, you can see this one, it's taking the last value, subtracting off the top one. And if I copy paste this across, if I double click over here, it's taking the last value, and it's still subtracting off from the top one, but it has moved the column. It's moved over to column Y, which is what I wanted, but it's still pointing at row 15. So anyway, that's the last step. Now we're actually ready to make a graph. So what we'll do is go ahead and just select all of our data, insert, scatter plot. Now, I usually do a connect the dot scatter. Your TA might prefer otherwise. I'll just do this one for right now. And this looks like crap. Now, if you get this, and sometimes I notice this on Mac computers more often than PCs, don't worry about it. As you can see, Excel has highlighted the data it's pointing at. It's highlighted this data in a purple box and this data in a blue box. Right now, Excel thinks this data is the X, and everything else is the Y, but we know this should be the X, and all of this data should be the Y. There's a very simple fix. You just right-click on some of your data, go to Select Data, and then switch row and column. There you go. That's much better. This is what your first graph should look like. We're actually going to make 2 graphs today. So you can also do this button right here. Gives you a quick layout thing, so you can insert a title and label your axes. We're also definitely going to want to label these series. Series 1 through 6 doesn't really mean anything, but let's go ahead and label our axes really quick. So this is our concentration of product, and the units are micromolar. Down here, this is time in minutes. It goes up to 2 minutes. So time, minutes. And then the title, we could call this oops. Sorry about that. Let's try that again. So title of my graph, I'm going to call that concentration of product versus time. Now, one more thing really quick we'll do is we'll get these so they have sensible labels. A quick, easy way to do that, you can actually right-click on your data and go back to Select Data again. And what we'll do, you have your series 1, 2, 3, 4, 5, 6. You can click on Edit, and then it's a series name. And if you click on this button, it allows you to click on what you want to call it. So I'll just click on this label I provided for myself and hit the Enter key. You can see this changed over here to 250. Click OK. Now I'll do the same thing for series 2. Edit, click on this button, click on my label, Enter key, click OK, and down the line we go. Okay, last one, series 6, edit, click, select the label. Okay, so now we have some sensible labels in our legend. We've got our graphs, they're all nice lines. Now, this is just concentration of product versus time. You are specifically asked to make a graph of initial velocity versus enzyme concentration. How do we get velocity from this graph? Well, keep in mind, velocity is essentially just like velocity of a car, miles per hour, concentration over time. If you recall from algebra, the units of the slope is the rise over the run, the y over the x. So the slopes of these lines would be concentration micromolar over time, over minutes. So basically we just need to do a trend line. So we'll do add trend line, and I'm sorry, I'm using a slightly older version of Excel, so it might look different on your screen, but basically you just do add trend line. It's going to be a linear trend line, of course. Display equation on chart, because we do want to know what that slope is. And that's all we really need to do, so I'll click close. And here's our trend line for that first line. Now, one thing I would recommend when you do this, you want to make sure, no matter what your graph looks like, you keep track of which one's which. So I'll usually pick these up and move them off to the side. But for all of these, I'm just going to add a trend line, move my little equation over so I don't forget which one's which. And you can always resize your graph if you have trouble with the ones down in the bottom, if they're getting a little too close together. And then I also like to delete these from the legend. Really don't need them, and they're just taking up space. Add trend line. This is the only part that's a little bit tedious, and if there was a faster way to get them all, I would be telling you right now, but it's not that bad. Add trend line, last one. Alright, so we've got these trend lines. And these are our slopes. These are all y equals mx plus b format. These slopes are essentially your velocities, concentration over time. And then these are enzyme concentrations. We need to make a graph of velocity versus enzyme concentration. Velocity versus enzyme concentration. So just over here on the side, enzyme concentration is going to be on the x, so I'll type that in first. Because, as you know now, Excel expects the x values on the left side and the y values on the right side. So this is velocity. It'll be velocity versus enzyme. And then we just copy these values. Just literally, what you see here, just type them in. So 250, 125, 50. And then the velocities, you just copy what the slopes are. Right. 76, 44, 19. It's very critical that you get these paired up correctly. That's why I was very careful to drag these over and keep them in a nice order. When you get down here, it can be very easy to get them mixed up if they're overlapping or if your data is not too good. So just make sure they're paired up correctly. So now we're going to make this graph. Again, we'll just select our data, insert, scatter plot. I'm going to choose a connect the dots scatter. And here's our graph. Just quickly do a quick layout. Really don't need the legend on this one. And now let's label our axes really quick. So what was this? This was our velocity, putting it on the y-axis. And as you can see, if you ever get confused, the highest one's around 70 to 80. There's our high value of 76. So velocity. What are the units of velocity? Well, over here, remember, velocities were the slopes. Slopes are rise over run, so it's the units of the rise, the y, over the units of the x. So our units of velocity are micromolar per minute. I'll just use proper Greek symbols. Micromolar per minute. What's down here? This is our enzyme concentration. What are the units of our enzyme concentration? Well, taking a look at the lab handout, following the instructions, says 250 microgram per milliliter. So that must be our units. Insert symbol, microgram per milliliter. And then the title of our graph. Velocity versus enzyme concentration. Basically what you need to do for week 1. So you basically have these 2 graphs. Your TA may ask you to only hand in this one or both of them, but both of these are probably going to need to be on your report, again, depending on your TA. Now, Dr. Lefler talks about this in his recitation video, but the whole point of week 1, again, is to select a proper enzyme concentration. Now, as you can see from this graph, this example data, we pretty much have linear velocity for all the enzyme concentration, so we might want to pick 250 in this case. Your data will probably look different. But that is week 1. There will be a separate video discussing week 2, which is certainly more involved. However, the steps are very, very similar. We're going to have to get a graph that looks like this, get the slopes, make another graph. It'll look something like this, but it'll be called the Michaelis-Menten plot, and that's pretty much that. So, thank you for watching.